if we start with the square root of 12. Now, is 12 a perfect square? We're interested in, it's like reducing it is what I call. Is it a perfect square? Was it in our list of perfect squares? Okay, look at the process of what we're going to do. Let's go over here. I need to find a place to do it. Now, I don't know if you want to do birthday cake or upside down birthday cake. I think I'm going to start with birthday cake because it just sets up like our old division. And I want to start factoring 12. Oh, is it prime? It's not, is it? So we need to start finding its prime factorization, its factor tree in terms of prime numbers. The smallest prime number is 2, and I start, if 2 will go into it, I start with 2. I'm going to tell you that's the most organized way to do it. And then 2 goes into 12 6 times. That prime. You want to stop when it's prime. Is that prime? No, and I keep going with 2. Now you might want to do 3 there, but I'm going to, I keep dividing by 2 as long as I can. 3 is 3 prime. So I stop. So the square root of 12 is the square root of 2 times 2 times 3. Now I'm putting a lot of steps in here that we'll abbreviate here in just a few minutes. Now I'm looking for perfect squares. It kind of goes back to what we did right here. Just see a set of perfect squares right there, because I know 2 times 2 will give me 4. So I'm going to write big square root, and I'm going to say 2 squared times 3. Now because I know this rule, I am not going to put that as a 4. I'm going to leave it as 2 squared. Now, there is a rule, and we'll address it a little bit later, probably Friday, maybe, Friday, Tuesday, that I can take this now, as long as it's multiplication, and I can break it into 2 square roots, or 3, or ever how many I need. Now, do I know the square root of 2 squared? Yeah, we just did it over here. So the square root of 2 squared is 2. The square root of 3 is a prime number that I can't break down other than 1 point something. And by the way, it's irrational. Do you know what that means? If you punch it in your calculator, it never ends. It never repeats. It's irrational like pi. That's always the best example I can give you. There's no fraction that's actually equal to it. So it's estimated. Now, that means multiplication. That means 2 times the square root of 3. And that is the simplified form of square root of 12. And that's the way we do it in math classes. And they like to throw that onto the ACT. 75. Let's do the factor tree. Do y'all like the upside down better? Well, I'll tell you one thing about the upside down. You don't have to worry about saving space. See, if I start it up here, it's going to kind of run into the work. So with upside down, you're going down the page. So I'm going to do upside down. I'm going to put the 75, and I'm starting it with a prime. Is 2 go into it? Does 3 go into it?
Yes.
Does it? It does. Now, if you forget it, and you don't do 3 and you do 5, you'll still get it, but at least mine will be organized as I go through it, and I get 25. You definitely want to use your calculator when you're doing your classwork. Now, if 2 wouldn't go to start with, it won't go now. Will 3 go? No, but will the next one up, 5, go? And you have prime. Now, we're going to do our work over here instead of over here. So I'm going to circle this. Is 5 times 5 a perfect square? Is it? So watch what I'm going to do. I'm going to put square root of 5 squared times my leftover, which was 3. These have to multiply to 75. Now, let's continue to put the extra step in it. And so I probably will skip that one in a minute, but I don't want to skip too much. And so I get the square root of 5 squared times the square root of 3. The square root of 5 squared is 5 times, and it's like 5x. We know 5x means 5 times x. So 5 times the square root of 3, and there's my simplified answer. The number under the square root won't necessarily be prime, so that may be a little bit deceiving. We're looking for perfect squares in these numbers. See, 25 goes into it. 4 goes into it. That's what we were actually doing. Number 3. What if we throw a number in front of it? Let's do 8 times the square root of 20. Now, that's just a number like this 5 right here. It's just a coefficient, and we're just going to tag him along. And we're going to break our square root of 20 down by its factor tree. 20, and for time's sake, I'm going to just kind of run through these. I always start with 2 or 3 or 5 or 7, wherever it starts. Goes 10, and then 2 goes again, 5. Now, over here, I'm going to write 2 squared times 5. Now, we're going to skip another step. without separating these like this, I know they can be separated. So I already have an 8 out here. I know the square root of 2 squared is 2. All of this is times, no adding and subtracting. We'll do that Friday or next week. But we're left to square root of 5. We can't break him down. I mean, he's 1 times 5. I can't do anything else to him. And so when I clean it up, I've got 8 times 2 on the outside, and I've got square root of 5 on the inside. 4. Got 2 more. 3 times the square root of 600. So you've got a 3. And let's do the factor tree of 600. If you just start with 2, then you're going to just keep going up as you do them. So 2 goes 300. 2 goes 150. 2 goes 75 times. See, I like doing all the 2s, then I do the 3s. But if you mix them up, that's fine. And then 5 and 5. Now, you know multiplication is commutative, which means you can rearrange it any way you want to. So watch what I'm fixing to do. Do you see any perfect squares? Okay, which means I'm looking for a pair of numbers that are alike. So 2 times 2 is 4, right? So that's a perfect square. I see another one. Yeah, 5 times 5. Let's circle that too. You're going to want to do that because watch, and I'm going to commute it. I'm going to put the 2 squared here. I'm going to put the 5 squared here. And I'm going to put my 2 and 3 that are left over right here. Now, those are prime numbers. Yes, so that's what we wanted. We want everything under here prime. 2, 5, 2, 3. So I've got a 3 already on the outside. The square, and when I teach this, usually in Algebra 1 for the first time, I make them circle the perfect squares so that they remember they get everything out. So the square root of the 2 squared will be 2. The square root of the 5 squared will be 5. And what's left inside? What is that? 2 times 3 is 6. Now, 6 is not prime, but its factors are 2 times 3, and neither one of those are perfect squared or can be paired with. So you don't have another 2 to pair it with. You don't have another 3. It'd have to be a 4 or a 9, and I don't have that. So when I finish cleaning it up, this is 30 times the square root of 6. You want to always take it all the way down. Number 5. 3 times the square root of 49. 49 a perfect square? I mean, you can do its factor tree if you want to. The factor tree of 49 is 7 times 7, so that's just 3 times 7, which is 21. Going, oh, because sometimes you get focused and you're not thinking, oh, I got to do factor tree, and you don't think about it being perfect square. Let's do the factor tree of 100. Why is it a perfect square? 2 goes 50, 2 goes 25, and 5 goes 5. Look what happens. It's the square root of 2 squared times 5 squared. Now, there's a 1 under there, times 1. And so you've got a 5 on the outside. You've got a 2, square root of 4 comes out. Square root of 25 comes out. There's nothing else left under there. Square root of 1. And so that was a perfect square, which I would have just said 5 times 10. But if you forget and do this, it's still going to do what you want it to do. Because it's going to be 10 times 5, which is, Ms. Brown didn't leave enough room, 50.